Hi everybody and welcome back. We're going to be looking today at matching equations in graphs. So the first example we're going to be looking at is matching equations with graphs that pass through the origin. Now, if we slide down here, the origin is going to be 0, 0. Now, looking at these lines, they don't go through it perfectly. That's just because the lines have moved off a little bit. They should be going exactly through the point of 0, 0. But with these lines, you'll get the idea of what this is going to look like. So, the important thing here is we look at, well, how many lines do we have? Well, we have 3 lines, and that's going to match up with 3 different equations at the bottom. So we also need to pick a value for x that is going to be consistent. In this case, I'm going to look for a value that is going to be found on the graph. So I'm going to choose an x value of 1 because it's going to pass through a point, and we're going to be able to determine based off of that point which belongs to which graph, and there's no overlapping, so we don't have another line, for example, passing over the same point. So if we use x as 1, we'll be able to determine the different equations for the different lines. Now, our first line that we're going to be looking at is y equals x. So y equals x, and we've chose a value for x to equal 1. So I'm just going to write that down so we remember x equals 1. So we'll input 1 for x, and that means y is going to equal 1. So when we have x as 1, y is going to be 1. Let's see what happens for our next graph. We're going to use y equals 2x, y equals 2, input your value of 1 for x, y equals 2. So when x was 1, y became 2. Now this is our last one, y equals negative 3x. So y equals negative 3x. Y equals negative 3. Input your value of 1. Y equals negative 3 times 1 gives you negative 3. So when x was 1, y was negative 3. Now we can look back up on the graphs. These are going to be our points that we get plotted. So 1 and 1, when x is 1, so we move from the origin over to 1 and move up to 1. This will be our point right here. Get rid of that last line. I'm just going to back out. So a point of 1 and 1. So this formula matches up with that line right there. Next one, we had 1 and 2. So x is 1 and y is 2. So this spot right here, so that line is going to go with this equation. And our last one, we have 1 and negative 3. So when x is 1, y is negative 3. So that means this line matches up with that equation. So for our first page, we are able to take the equations that all pass through the origin and match them up specifically with their line. On the next page here, it says we're going to be identifying a graph given its equation. So the equation that we are given is y equals 3x subtract 4. Now if you look at the graph here, we have 3 different lines, line A, line B, and line C. None have a similar point that they are going to pass through because they're all parallel to each other. So that means if we choose a value for x, we'll be able to determine based off of what the y value is, which line it is that we're talking about. So the formula that we're looking at was y equals 3x subtract 4. Now again, I'm just going to choose a value of 1 for x because I'll be able to see that on the graph. So if it falls anywhere along here, I'll know what my y value is. Back over to the equation, equals 3, input your value of 1, subtract 4. Y equals 3, subtract 4. Y equals, now 3 subtract 4 gives you negative 1. So when I chose a value of 1, for x, my y value ended up as negative 1. So I want to find the line that's going to match up with this point that I can plot here. So move from your origin over to 1, move down to negative 1, and this is your point here. So we know that this equation matches up with line C. Now we'll move over to our last page. We're looking at example 3, which is identifying a graph given its equation. So the 3 graphs below have these equations, but the graphs are not in order. So we're going to match each equation with its graph, use the equation to determine coordinates of 3 points. So this is important here. We're going to look at 3 different points for each equation, and then we're going to find which graph passes through those 3 points specifically. Now the equations that we are using are right here. So we have the 3 different equations and we have our 3 different graphs. Now, because I already know this, but if you look quickly, there's a point here where 0 is your x and y is 3. 0 is your x and y is 3. So this is why we're going to have to do 3 different points for the equations, because you're not going to be able to determine which equation belongs to which line just off of that one point. Because if you did 0, you wouldn't be able to tell the difference between them. So you have to find multiple points on that line to be able to distinguish the difference between them. So the points that I'm going to use are negative 1, 0, and 1, because we'll be able to see that on the graph and we'll be able to find our y value. So we'll start off with our first equation. Y equals 3x plus 3. Y equals 3. Now I'm going to use my negative 1 plus 3. Y equals 3 times negative 1 is negative 3 plus 3. Y equals negative 3 plus 3 gives you 0. So when I chose a value of negative 1 for my x, my y was 0. We're going to do this with 0 now, and then we're also going to do this with 1. Same equation. Y equals 3 multiplied by 0 plus 3. Y equals 0 plus 3. Y equals 3. So when x was 0, y was 3. Last one, same equation. Y equals 3. Now we're multiplying by 1 plus 3. Y equals 3 plus 3. Y equals 6. So when x was 1, y was 6. So we have to look at the 3 different graphs now and determine which point belongs to which graph. Now, if I look for my first one here of x as -1 and y as 0, well, we know it's not going to be this one here. It's not going to be this one. This one does match up with it. But to make sure, though we already have eliminated the other two, since we did the work anyways, we might as well find the points. So 0 and 3 and 1 and 6. Now that does go just off of my graph there, but you can tell that it is going to go to that point. Now we'll look at our next equation here. We have x plus y equals 3. Well, I don't like to work with it that way. I'm going to change this around so that we isolate y. We want to change this into y equals, now it's going to be negative x because we're moving it to the other side. You're doing the opposite, plus 3. So that's the equation we're going to be working with. Y equals negative x plus 3. And we're going to use the same values for x, -1, 0, and 1. Y equals negative, and now don't forget we're putting in our -1 plus 3. Y equals, now because we have a negative and a negative here, it's going to become positive. 1 plus 3, y equals 4. So when x was -1, y was 4. Continue this on. This time though, we're putting in a value of 0. Y equals negative times 0 is still 0, plus 3. Y equals 3. So when x was 0, y was 3. And our last point that we're going to use for x is positive 1. Y equals negative, input your 1, plus 3. Y equals -1 plus 3. Y equals -1 plus 3 gives you 2. So when your x was 1, your y was 2. Let's find this on the graph now. So we're looking with the graph with the first point of x being -1 and y being 4. Look at this graph here. We go to -1. We go up to 4. Well, this is a good match. We should double check though on the other graph if it's gonna. Well, this one doesn't match. So we know that that one's not going to be the one. Now, since we did do the other 3 points, I might as well find them. So there, and your last one is right there. Now, with your process of elimination, you know that this graph belongs to that line. This equation belongs to that graph. And process of elimination, this one will belong to that graph. Now, I am going to do the work for this one as well. So what I want you to do is complete the work for this and then check the answers in OneNote so that you know you did it correctly. Other than that, that's going to be the lesson for today. It's nice and short, and you can continue on with the worksheets that follow.